So far, we have used quite a few of Python's built-in functions, like input, print, sorted, and range, to name a few. And what we are going to do today is learn how to create our own functions in Python. And you'll also learn different ways of storing those functions and pulling the code into your program. So a little background on functions first before we get into actually creating them. A function is a block of code, and it only runs when it is called. Functions should be designed to perform one task only. If you find that you have a function doing all sorts of different things, that is a clue that you should probably break that down into additional functions. Functions can return data, and they can also accept data. The data that is accepted is called a parameter when you are defining the function. When you're actually calling the function and you're passing the data, it is referred to as an argument. When should you create a function? If you notice that you have the same lines of code repeated within a program, that is one clue that you should actually pull out those repetitive lines and put them in a function. Having them in a function will make testing your program much easier. And if you have to update the program, it will make maintaining that program much easier. Another reason to create a function would be if you wanted to share code. So you can share code with your teammates on your development team, or you can share code amongst your own programs. So sharing code is another big reason to create functions. So how do we create functions? The way that you create a function really depends on the purpose of the function and what it's going to do. Because you can create functions that have no parameters, you can create functions that have parameters, and you can also create functions that return data. So, how you create the function is going to be dependent on what that function does. So the syntax for no parameters is you start with the def keyword for define, and then a space followed by the name of the function. After the function name, you need a left and a right parenthesis. So even if you're not going to use parameters, you still need to have the left and right parenthesis, and that function definition line ends with a colon. All of the lines that you want the function to execute need to be indented. So what about if your function needs data passed to it? Well, then you are going to have to define parameters. So you still use the def, def keyword, followed by the function name, but instead of empty parentheses, now you put in variable names that you will associate with the data that is being passed. And you need commas between these variable names. Still ends with a colon, and all of the statements that you want to execute still need to be indented. So I have a little example here where the name of the function is called square, the parameter that's being passed, we are naming that data number. And then the function just has one line that it executes, and that is a little message that says, whatever the number is that got passed, squared is, and then it displays the square. So in addition to creating functions with no parameters, functions with parameters, you can also create functions that return values. The function header doesn't change. So you're still going to have def or define and your function name, and then the parentheses, and then if it needs data, you're going to have those parameters and the colon at the end. Then you have all of your statements, and in those statements that are executed, you need to specify a return keyword followed by whatever it is that you're returning. So you don't need any kind of data type up in the function header, which is the first line of the function. All you need is the keyword return followed by whatever it is that you're returning. So here's that same example of the square function, but instead of printing the results, now it's just returning the number squared. And so we'll quick code up both versions of that little function. And first, we'll start with the one that is accepting the number parameter and printing. So how this would work is we have to actually call the function. And we've called functions before. That's what we've been doing with print and input. So to call this one is really no different. It's not returning anything, so we don't need an assignment statement. All we need is the name of the function, and in parentheses, we have to send it a number. And then we can run the program. Okay, and it says 10 squared is 100. 10 is the number I passed. So instead of printing the message, what if we just want to return the number squared? Okay, so if we want to return the number squared, we need the return statement. And square still calls it, but now it's returning a value. So we should have an assignment statement here. There's two ways you can handle it. You can store the returned value in an assignment statement. And so I'll just call it squared number equals. Okay, so you can do it like this, and then you could do a little print number squared is something like that. And you can see the result down here. Or another thing that you can do, if a value is being returned and you want to use it in a print statement, instead of storing it in a variable, I'm going to comment that out. What you can do from inside your print statement is call the function. And then it's going to return a value that will be displayed right in the print statement. And you can see the result looks the exact same as before, but we didn't have to store the value. We just directly printed it. So calling functions and passing arguments. The traditional method of calling functions requires positional arguments, meaning if you have more than one argument, the position matters. Python also allows something called keyword arguments. And with a keyword argument, the position doesn't matter. So we're going to take a look at how to code both and what the difference is. With positional arguments, the location that you put the data when you call the function matters, okay, because it's using the position in the function to determine, what parameter goes with what piece of data. So in this little example, we have two different parameters in our function. So let's copy that example. Okay, and let's say we want to call that function. So the correct order here is going to matter. So we want to pass it the type of animal first, followed by the name of the pet. So it's not returning anything. So we're going to say describe pet, and we will pass it the animal type. Let's say it's a horse, and the animal's name, we'll call it Lightning. Okay, so this is in the correct order, so the output is going to make sense. I have a horse, my horse's name is Lightning. Makes perfect sense. If we mix up the order, which I will do in the next one, it's not going to make sense. So if I have a fish, and let's say the fish's name is Frankie. So if I send it the name first and the animal type second, it is going to line up the very first argument with the first parameter. So it's going to think Frankie is the animal type and fish is the pet name. Okay? And that is the problem with positional arguments. And this is how most languages handle functions. When you pass arguments, they are positional. So whether you have a return statement or not, the arguments that you pass still are going to be positional. Okay? So it doesn't matter if you're returning something or not. If you use keywords, then the position of the arguments that you pass when you call the function, it doesn't matter because it's matching up the data based on the keyword. So for this second one, if I put in the parameter variables and assign them values, they become keywords. So to do a function call using keywords, all you need is those parameter variables, and you assign them, you do an equal sign, an assignment statement, you set them equal to the value that you're passing. So if I do that, I can do pet name equals Frankie, and it doesn't matter if I pass it first or second. And I can do animal type equals fish. And again, doesn't matter what order these are in because I am actually using the parameter name in my function call. So when I run this, both of them are going to make sense. The first one will make sense because it's in the correct order. The second one, I'm now using keywords. And so it is lining everything up based on the keyword. So it's going to take pet name And up in the function, because those match, it's now going to assign pet name Frankie. And then for animal type, up in the function, it's going to assign animal type to fish. So it's going to make total sense when it prints the information out because we're using the keywords. And again, it really does not matter if you are returning values with this or not. Okay, because the return statements are handled the same. What matters is if you are using the parameter names with an assignment statement in your function call. So for fun, we'll just do another little one here. This one is expecting two numbers. The first parameter is number and the second one is power. Okay, so if I was to use positional, I would have to make sure that I sent it the number first and the power second. However, if I use keywords, it really doesn't matter what order I send it in. So this first one, I happen to be sending it in the correct order, but let's do another one where I don't send it in the correct order, just so you can see that does not matter with keywords how you send things. So the second one, we flip-flop that around. We'll send it the power first and the number second. And it'll work just fine because I've got those keywords in there. So let's run this. Okay, so 5 raised to the first power is 5, 8 raised to the second power is 64. Both of them worked. Okay, and both of them are using keywords. Now, what if the first one wasn't using keywords? Well, that one would still work because they are in the right position. Okay, so if I run it again, it's still going to work. So what if you have a function and it's expecting data to be passed and part of the data gets passed, but not all? Well, normally, your program is going to have an error. However, you can specify default values that Python will use if the user doesn't send all of the required information. So in our little number raised to a power example, if we wanted to have a default power of 2, we just set power equal to 2 up in our parameter list. The minute we do this, number is now required and power is optional because if they don't pass a power, we are going to use 2. So what we'll do with our first example is we're going to get rid of the power. So it's going to use 2. And our second example we'll leave alone. Now, what happens if you send it a power and there's a default value? It's going to use whatever you send it. Oops, and I should have changed my description because that is deceptive. So this one is actually going to be raised to the second power because we're using the default. Let's run it again. 9 raised to the second power is 81. 1 raised to the first power is 1. Okay, so you can see the difference there. It automatically used the second power. You can run it again. You'll get a little different results every time. But for the first one, no matter what random number it retrieves, it's always going to be raised to the second power, unless we now send it a value. The second one, it's going to use two different numbers. Okay, so it's always going to be raising to a power, and each time it'll probably be different. Okay, now what if we wanted to hard code and pass a power? We can do that. Okay, then we probably should change our description though, because we know how confusing that is if it doesn't match. That'll work. So if we pass it a power, it's going to use what we pass. 5 raised to the third power is 125. Okay, so it is pretty flexible. Default values are a good idea, especially if you are unsure of whether somebody is going to pass all of the required information, because it does allow the program to continue running. So a little summary of function calls. Some key things to remember. What determines if arguments are positional or if you are using keyword arguments is the function call itself, not the function. The function is coded the same way, regardless of if you are using keywords or not. So it's the actual function call that is determining positional or keyword. The function itself is going to determine whether the parameter is optional or required. If you have default values, then that particular parameter is optional. If there is no default value, then the parameter is required. A function can be called using positional arguments or keyword arguments or a combination of both. Okay, so if I wanted to do a little combination here, let's say you'd probably need more than 2. Yeah, it works better if we have more than 2. 2 parameters doesn't make a whole lot of sense. So let me change this quick. So we'll just say sum. And we'll have number 1, number 2, number 3. Oh, we'll throw in another one, number 4. Actually, let's call it result. And we will return number 1 times number 2 times number 3 times number 4. Okay. And we'll set number 3 equal to 2, number 4 equal to 1. Okay, so just for fun, we set a couple default values. And why don't we just print a result here? So we're going to say result And we'll just send it 2. So when we do this, number 1 is 10, number 2 is 20. Okay, so it's going to give us that result. Now, what if we want to do this a little different? So what if we want to pass it 10 for the first one, and then we want number 4, we're going to set that equal to 2. Number 2, we're going to set equal to 5. And we'll leave number 3 on the default. That will work. And so this is what it's talking about, where you can mix it up, right? So we're going to be using a default for number 3. 10, we don't have a keyword, so that's going to come in as number 1. And number 4 is going to be overridden here, so it's going to use a 2. And number 2 is going to be a 5. So if we run this, our first little result is going to be 10, 20, 2, and 1. So that ends up being 400. Our second one, we've got 10, 5, 2, and 2. And you can see the result for that one. You will get errors if you forget the required arguments, or if you're using keywords and you miskey a keyword, like you do a typo. For positional arguments, you may get an error if you put them in the wrong order. However, in this numeric example, I mean, if I'm sending it 4 numbers and I put them in the wrong order, it's not going to matter. Okay, so I mean, if I had wanted 2 to be number 4 and I put it here, it's not going to raise an error because I'm still sending a number. My result might not be the same, you know, especially if I change the equation to something like this, where I'm doing multiplication and addition. Okay, then that could impact my result, but the program will not have an error because I'm sending it valid data. So how do we handle dictionaries and lists in functions and function calls? Basically, if you are going to be returning a dictionary, you assign the dictionary key value pairs to a variable, and you just return the variable. Okay, so this little example is going to calculate BMI. You can see we have defaults set for weight, height, and age. So hopefully they'll pass us data so they can get their actual BMI. Otherwise, they're going to get the default BMI. But you can kind of see it does a calculation. It's got like a little message it displays, and then it's got this little health dictionary that it returns. Okay, and you can see we're calling it here and passing it the different information, using positions, using keywords, and then we're printing out the dictionary that gets returned. And this is kind of how it looks. And here is the same example in a while loop, okay, where we say how many clients you want to enter, and we get into this while loop so they can enter the number of clients they want. And here it's prompting for the weight, prompting for the height, prompting for the age, and then passing along that information. The information that is returned, it simply prints out and adds them to a little list. So this is a list of dictionary items, right? Because what the function is returning is a dictionary. And when we append to the list, each one of the entries in the list is going to be a dictionary item. Okay, so if you want to run this, you can, just kind of to get an idea how it works. So down here, how many clients are you going to enter? I'm going to do 2. Enter the weight, the height, the age. Okay, so then it prints out that client's information, and this ends up getting added, appended to our client list. Now I'm going to do the second client. And that information got printed. And then it went down here and it printed everything that was in our client list, which at this point is 2 dictionary items. This example is similar. What it's doing is it's calculating a target heart rate. So it's expecting age and resting heart rate to be passed. If they don't, it's using some default values. And again, we have the while loop where they enter the age and the resting heart rate. We call the function. It's returning information, and then we're printing that information out. What it is returning is a dictionary. So when we return here and store it in heart info then becomes a dictionary. And then you can see that we are appending it to a list. So each one of these heart info dictionaries are going to be added to a list. And then this example is from the book. So basically it's just formatting the name and it's returning it. Okay, so this is how you would do an F string, just so you know. So that was an example of returning a complex database or database data type. This next one is an example of how to pass a complex data type to a function. So with the function parameters are going to be bringing in the complex data type. And you'll notice that we don't really do anything special, right? We just have the parameter names. So then down here, you'll notice that we have a list with some data, a list with no data. We call print models and we're sending it both lists. So what does print models do? It basically simulates moving a item from unprinted over to the printed list. Okay, so when we call print models, we're sending it both. We get into this while loop where we take the last item off of unprinted, store it, print out a message using that item, and then we add it to the completed models list. Okay, so we pop off the end, print it, add it. Okay, and we stay in this loop as long as there is something in unprinted designs. Okay, once that finishes, then we call show completed, and we're only sending it the completed models, which in this case should be full. So we get into show completed. Completed models is a list. And then you'll notice we get into a for loop. So this is something that is really important that you remember, and I kind of noted it down here. If you are modifying a list and you are removing items, you have to use a while loop because Python gets very confused if you start removing items from a for loop because it's expecting every single item to be there, and it actually throws it off and it will skip over items. So you definitely want to make sure that you use the while loop if you are modifying a dictionary or a list. So just to show you what happens if you try to modify using a for loop, what happens is it gets confused and it will skip items. So let me show you what ends up happening. Oops, indentation error. So what don't I have indented? Oh, I see. No, that's indented right. The comments. Oh, that needs to be over. Or this needs to be over. It's very fussy about this. All right, I think it'll run now. Nope, it's still not happy with me. See, this happens to me too. All right, it does not like where I'm indenting. Let me hold this a sec, and I will fix this. All right, so what I had to do was kind of line these. I don't know if you guys can see these, but there's some lines, vertical lines. So I kind of lined everything up on the vertical lines, and now it runs. It's very fussy about that. But running this, you can see that the unprinted designs had 3. And so when it was processing in the for loop, it skipped one. Okay, and it typically skips the item after the one you remove. So if I would have had a 4th item on here, it would have skipped that too. So if we run it again, okay, it's still just going to do the first 2 because it's skipping the one after the removal. Now, if I get rid of the for loop and I remove the comments on the while loop, let me see, I've got my while. Okay, everything's lining up. It should work. With the while loop, what's going to happen is it's going to actually remove everything. Okay, and adds it all to the other list. Okay, so that's why you need to use a while loop, especially if you are modifying or removing anything. This next example basically shows the same type of thing. It's passing in a couple different lists and updating users if the new users are valid. So we're pulling in current users and users we want to check. We have a list called lower current for lowercase. And then we're basically converting all of our current users into lowercase and storing them in lower current. And then got a little for loop where we are checking for a user in lower current. So if the user ends up being, the one we're checking ends up being in our current list, that username is being used. Otherwise, it's available and they can use it. That's all it's doing. This third example passes 3 dictionaries to a function, and like I said before, it's just passing parameter names. So in the processing is where you can kind of tell that it's a dictionary. Okay, so here are the 3. And then in this particular function, it's just printing information out. If we want to prevent a function from modifying a list or a dictionary, what we have to do is modify the function call. And you simply add brackets with a colon, and then it will not allow that particular list or dictionary to be modified. So in this example, if I tell it not to modify unprinted designs, up here where it would normally remove the last entry, it's not going to do that. What it does instead is kind of interesting. It copies that entry into current design so that it can still modify completed models, right? It can still do the update there. It just doesn't remove it from unprinted designs. So to see that, I'm printing out each one of the lists after the program is done running. Okay, so you can see at the bottom, unprinted designs still has everything in it. It's not empty. And completed models has the data that was copied in there, that was appended. Now, what happens if I prevent it from updating completed models? Well, then nothing is going to change. They're going to be the same as they were when I first created them. Okay, so you can see down here, nothing has changed and they look the same. So far, we've looked at how to pass a variety of data types to our functions and how to return data, how to use positional arguments, and how to use keyword arguments. But what if we don't know how many arguments we are going to be passing? Python has a workaround for that, and other languages allow this as well. What you need to do in front of the parameter name is insert an asterisk. Okay, so in a positional argument, putting the asterisk in front indicates that the number of arguments is going to vary. So this is a little example from the book. I thought it was pretty appropriate for illustrating how this works. We have a function called make pizza. We have no idea how many toppings somebody might want. And so it allows for a variable number. And here we have 2 function calls sending it different number of toppings. So you can see when it prints out, it does allow the different numbers to run through that particular function. So if we are using a keyword instead of positional, This is one instance where you actually have to change the function header. Because if your users are doing keyword arguments and you want an unknown number of arguments passed in the function header itself, which is the first line of your function, you need 2 asterisks. So for positional, you need 1, and for keyword, you need 2. So we can take this little example with keyword arguments. Oop. And here we have 2 asterisks now. And the reason that we don't know how much is going to be passed is first and last names are required. And then we have no idea how much user information they're going to pass. So for the first one, we've got the first and last name, and then we're sending it location and field. And for the second one, we're sending it the first and last name, and we've got location, occupation, and hobbies, totally different information. So this makes perfect sense for this to be a keyword because of the way we are passing the data. Okay, we are doing a key value pair with it. So let's go ahead and run it. And you can see that we are printing a user profile, which has the first and last name. Okay, and then also has that key value pair information. And you can see that we are building this profile as a dictionary. How can I tell this is a dictionary? Well, we're adding a first name and last name to user info using keywords and values. So this is a dictionary that it's building. The keyword becomes the key and the value becomes what is being stored. Now, quite often, how you will see this, instead of user info, they may just do keyword arguments and abbreviate it as KWARGs. Okay, so just kind of be aware of that. And will that work? Let's run it that way. Yeah, it doesn't like that just because user info now doesn't exist. I mean, I could put keyword args here, but to me that doesn't make as much sense. But don't be surprised if you see keyword args in other programs. All right, let's run it again. Okay, and so now we have that. In our main program here, it's still being stored in user profile. It's just that up here in the function, it's now using keyword arguments. So what's better, giving this a more descriptive name or using keyword arguments? It doesn't matter. It is a convention in Python to use keyword arguments, so it's up to you. Now, this brings us to function location and storage. All of the functions that we've been looking at so far have been located in the program that we are calling them. You can store functions outside of the program, and Honestly, storing them outside of the program in a separate file lets you take advantage of the whole reason that people create functions, because you can allow other developers to use your function if it is outside of your file. And we've already used functions that are outside of the program that we are coding. When we did import random, and then we called rand range, we were using a function that is part of random numbers. So we were bringing in a module and using its functions. So we've already kind of done that. Now you're going to learn how to create your own functions in external files, which are also called modules. And you'll learn how to import your own functions, just like we did with the random module. And that is considered best practice. Not only does it allow you to share the code with other developers and reuse your own code, it also kind of hides the details of your implementation. Because when we imported random, we had no idea what the rand range function does, other than, we have to send it a beginning and ending number, and it returns us a random number. That's all we know. Okay, so it does encapsulate the code. And that is part of best practice in object-oriented programming. So we are going to take a look at saving our functions in separate files and a couple different ways of importing them. So you can import the entire module, and that is pretty much what we've been doing. So it's just the keyword import followed by the module name. So when we did import random, we were importing the entire module. If we wanted to use a function in that module, we had to code the module name, random, a dot, and the function name. Okay, so that heart rate example that I gave you earlier, I took the functions for heart rate and BMI, and I put them into a file called health. Okay, and then I can import that health file, and that would allow this developer to use either one of those functions. But because I imported the function, or the module, if they want to use the function, they have to prefix the function name with health dot. Okay, so that is the way that we have been importing. And I'm going to go ahead and open up these examples so you can see what they look like live here. All right, so my little example here, I'm importing health. You'll notice I have some lines commented out because we're going to talk about those in a few minutes. For this particular one, I'm importing health. I'm only using calc rate. Okay, so I've got health.calcrate, storing the dictionary that it returns in heart info, and then I basically print out the information and add it to my list. So I'm adding a dictionary item to a list. So let's run it. How many clients are you entering? I'm just going to do one. Enter the client's age, 35. Resting heart rate, 60. Okay, so here's their training information. Okay, and it printed that out. So that's what we've been doing. That's how we've handled import random. Another way to pull in a module is to import everything. So if the module is small, and our health module is fairly small, there's only 2 functions in here. Some modules can be really, really big, but this one is not. Okay, so if the module is small, then doing an import asterisk may make sense. So let me change my comments here. So doing it this way, I'm actually pulling the functions into my programs. So I do not have to prefix the function with the module name. So I don't have to access it using the module name and a dot. I can simply use the function name. Okay, so what does this save me? It saves me the hassle of putting in health dot before the functions that I want to use. Okay, everything else works the same. So I enter one client, let me do their age, heart rate, and it's still returning the same information. Which method is better? If the file that or module that you're importing is small, it does not hurt to do import asterisk. There's no overhead from that. If it's large, then you might want to think of how many functions you're going to be using, okay? Because you're actually importing everything. Whereas when you say import health and you've got health.calc-rate, it knows you're only going to use that one function. So it's not bothering importing the other one. Okay, so there's some overhead involved with using the asterisk. So another method that you can use. You can be very specific as far as what you are going to import. So instead of just importing the module, you can import the module and the functions that you're going to use. So I can say from health, that's my module, import, and I can do the exact function names here. Okay, so if I'm going to use both, I can import both. So what does this give me? Well, I can still do calc rate with no prefix of health because now I am telling it pull in calc rate. And if I chose to use BMI, and just like magic, all the code appears, if I chose to use BMI, I can also use that without prefixing it with health. Okay, so using this is going to allow me to utilize both of these functions without prefixing it with anything. So let's run this. How many clients? Well, I'm just going to do one. Enter the client's age. Let's say this particular client is 65. Resting heart rate. So I just got the training information for heart rate, and now we're going to do the BMI. So the weight of this client and their height. Okay, so it's now calculating their BMI, and we're done. Now, if I was going to use, let's say, the calc rate function quite a bit, I may want to give it an alias. because calc rate is a lot to type and I'm a lazy typist. So, oops, what I can do is right after I pull it in, I can give it an alias of HR, which is probably a little more descriptive of what I'm doing because I am calculating the heart rate. So I can say from health, import calc rate as HR and import BMI. So my BMI line does not have to change. My calc rate one does because now I am calling calc rate HR. Okay, so for the function name, I'm now calling it HR, so that had to change. But the way the code runs is going to be the same. Okay, it's just how I'm referring to the function that has changed. So it does make sense to use an alias if you are going to be using the function in multiple places and the function has a lengthy name. In addition to giving a function an alias, you can give the module an alias. So what if your module has a really long, annoying name? We can give that an alias as well. So if we were going to do that, then we have to actually change both of these. And so if we're just doing that line, instead of calling it health, we're now calling it H. And we're not pulling in our functions, so we still have to do a dot and the name of the function. And I'm going to have to do the same thing down here with my BMI one. Okay, so I'm not calling it health anymore, I'm just calling it H. And when I run this, it's still going to run the same as it did before. How many clients am I entering? I'm just going to do one. Let's see. We'll have a young client here. They're very healthy. Their weight. Let's make them skinny. Let's see. So they are underweight. So that ran pretty much the same. Okay, the only difference is, how I'm pulling in the function. And those are all the different ways of importing. And the reason I went through this in such detail is because you are going to need to do something similar in the next hands-on. Okay, and this is pretty much the end of the lecture demo for functions.